In this video, we look at the MIT Integration P question. This is a 2024 final question, but it was the lightning round question. So let's see how we can solve this integral. This is actually very easy. We are going to transform these ones into the beta functions. And this integral actually evaluates to 0, so you may want to stick around to see the solution of this integral. So let's solve this integral. So let's start off by, I'm sorry about that, I should begin with a white pen. So let's start off by breaking this integral down into two different integrals. So the integral from 0 to 1 of this boy here raised to the power 3 over 2 dx minus the integral from 0 to 1 of 1 minus x raised to the power 2 over 3 raised to the power 2 over 3 dx, right? So I'm going to call this one integral 1 and this one integral 2 and tackle them one after the other. So the first one, let me do it in yellow pen. Why not? So I1 is going to be the integral from 0 to 1 of 1 minus x raised to the power 3 over 2 raised to the power 3 over 2 dx. Let's do a u sub here. We can let u to be equal to x raised to the power 3 over 2, right? So the limits of integration will not actually change, because when x is 0, u will be 0. When x is 1, u is going to be 1. So the limits will not change. Let's find an expression for dx. If u is equals to x raised to the power 3 over 2, that implies that x is going to be u raised to the power 2 over 3. This is it. And then we differentiate. Dx is going to be 2 over 3 u raised to the power 2 over 3 minus 1 is negative 1 over 3 du. So I can replace dx with this one. So our integral I1 is going to be the integral from 0 to 1. The limits will not change. 1 minus x raised to the power 3 over 2 is u raised to the power 3 over 2. And dx, what is dx? Dx is 2 over 3 u raised to the power negative 1 over 3. X, du, I'm sorry. So that is going to evaluate to a 2 over 3 is a constant integral from 0 to 1 of u raised to the power negative 1/3 1 minus u raised to the power 3 over 2 du. So we are now going to convert this one into the beta function. This is 2 over 3, the integral from 0 to 1 of u raised to the power negative 1 over 3. What number minus 1 will give you negative 1 over 3? That is going to be what? 2 over 3, right? So this is going to be u raised to the power 2 over 3 minus 1, because 2 over 3 minus 1 will give you negative 1 over 3. Times 1 minus u raised to the power 3 over 2. What number minus 1 will give you 3 over 2? That is equals to 5 over 2. So 5 over 2 minus 1 will give you 3 over 2 du. And this one, comparing this one to the beta function, you know that the beta function with complex argument m and n can be written as the integral from 0 to 1 of x raised to the power m minus 1 times 1 minus x raised to the power n minus 1 dx. So this our integral here is 2 over 3, the beta of 2 over 3, and then 5 over 2, right? So this is how the first one can be simplified. Now let's tackle the second one. The second one is this guy. So I2 is the integral from 0 to 1 of 1 minus x raised to the power 2 over 3 raised to the power 2 over 3 dx. That is this guy. Okay, so we are doing the same thing. Let u to be equal to x raised to the power 2 over 3. So the limits of integration will not change. So we have to find an expression for dx. So expressing x in terms of u, we have x to be equal to u raised to the power 3 over 2, right? So dx here is going to be 3 over 2 u raised to the power 3 over 2 minus 1 is 1/2 du. So I2 can be taken into the u world now. Integral from 0 to 1 of 1 minus x raised to the power 2 over 3 is u raised to the power 2 over 3, and then dx is 3 over 2 u raised to the power 1 over 2 du. And that is equal to what really? 3 over 2 integral from 0 to 1 of u raised to the power 1/2 1 minus u raised to the power 2 over 3 du. Now let's express this as a beta function. I2 is going to be 3 over 2, the integral from 0 to 1 of u. What number minus 1 will give you 1/2? So that is going to be 3 over 2 minus 1. and then 1 minus u raised to the power 2 over 3. What number minus 1 will give you 2 over 3? Well, that is 1 plus 2 over 3, and that is equals to 5 over 3, right? Yeah, so that is going to be 5 over 3 minus 1. So that's is how this integral can be expressed. And now we are going to compare that to the beta function again, comparing that to this one. So comparing that, we have this one to be equal to 3 over 2, the beta of 3 over 2, and then 5 over 3. So the first one is 2 over 3, beta of 2 over 3, and 5 over 2. And the second one is the 3 over 2, beta of 3 over 2, 5 over 3. Now, I is I1 minus I2. I1 is 2 over 3, beta 2 over 3, beta 2 over 3, and then what? 5 over 2. Minus I2. I2 is this. That is 3 over 2, beta of 3 over 2, 5 over 3. Okay, so that is going to give us what? So now we know that beta of m and n, the gamma representation of the beta function, this is gamma m, gamma n divided by gamma of the sum m plus n, correct? So let's use that to solve this integral. So I is going to be 2 over 3. The first one is gamma 2 over 3, gamma 5 over 2 divided by gamma of the sum. 5 over 2 and then 2 over 3. What is the sum? That is going to be 6. This is going to be 10 plus this is going to be 2. That is going to be this is going to be 15. I'm sorry about that. That is 15 here, and this is going to be 4. So that is going to give you 19 over 6. So gamma of the sum is 19 over 6. Minus 3 over 2, gamma of 3 over 2 times gamma of 5 over 3 divided by gamma of the sum, 3 over 2 plus 5 over 3. LCM is 6. This one is 9 plus this is 10. So that's the same 19 over 6. So this is 19 over 6 for the second one as well. And now we are going to use an identity. This one, we know that gamma of m plus 1 is the same as m gamma m. This is what we are going to use next in order to solve this integral. So gamma of m plus 1 is the same as m gamma m, right? So if you are able to express these terms here as gamma of something plus 1, then we are in business. So gamma of 2 over 3, that one I can leave that one as gamma of 2 over 3. What about gamma of 5 over 2? Gamma of 5 over 2 can be written as 3 over 2 plus 1 divided by gamma of 19 over 6 minus 3 over 2 gamma 3 over 2. Gamma of 5 over 3 can be written as what? Gamma of 5 over 3 can be written as 2 over 3 plus 1. That is 2 over 3 plus 1 divided by gamma of 19 over 6. Yeah, so that is gamma 5 over 3 can be written like this. So I is equals to, now using this identity, that is going to be m gamma m, right? So this is 2 over 3. Then you have gamma 2 over 3. Then this one is 3 over 2 gamma 3 over 2. That is this one. Minus 3 over 2 gamma 3 over 2 times this one is 2 over 3 gamma 2 over 3. That is using this one. All this one divided by gamma 19 over 6, gamma 19 over 6. So I is going to be, some things will cancel out, this will cancel that, and this will cancel this. And what are you left here? 2 over 3, gamma 3 over 2 minus This will cancel this, and this will cancel that. And what are you left with? Gamma 3 over 2 times gamma 2 over 3, all divided by, I'm sorry, this one divided by gamma of 19 over 6, this one divided by gamma of 19 over 6, and that is equal to what? The numerators are now the same. So the first term is equal to the second term, right? Gamma 3 over 2 times gamma 2 over 3 is the same as this one here, gamma 3 over 2 times gamma 2 over 3. So that is equal to 0. So the integral evaluates to 0. That is courtesy of the beta function, the gamma representation of the beta function, and this identity here. So that is how this integral evaluates to. So that is equal to 0. So it means that if you evaluate this integral, this MIT final question, the lightning round, this one evaluate beautifully to 0. So that is how to evaluate this integral. If you find this helpful, make sure to give me a thumbs up and subscribe to my channel for more content. I thank you so much for watching this video, and I'll see you in the next one. Bye bye.